Okay, so today we are going to discuss how to find the area enclosed by two curves. Suppose for example, we have some curve something like this and then another curve which is like this. Suppose we want to calculate the area between this curve. This is what we would like to find out the area. So, that means what we are saying, mathematically try to look at this. So, the curve which I have drawn, which is, that means there is an underlying function y equal to f of x. For this, let us say f of x, y equal to, and for this I have y equal to g of x. Okay. Now, that, so it is given to us that let f and g from a b to r, because we are interested to find this a to b, this region a b to r be continuous, and as you can see that let us do a very simple first a simple curve for us. Suppose this is the curve, this is a and this is our b, and I have another curve, this is my f and this is my g. Now, as we can see for this one, this is f of x is greater or equal to g of x. So, if you look at what we have done earlier is that if I find the area of this curve under f, then I am going to compute this area of this region. Now, if we are interested in finding the area under the curve G, the region bounded by the curve G in this region, this is going to be the area. Now, we are interested in the area between these two curves, lying in between these two curves. That means, what we are trying to find out is the area this region, and this is of course, for this picture what you can get is that f of a to b f of x dx minus a to b g of x dx, that by the properties of the Riemann integration minus of g x dx. Now, you can see that the difference between this picture and this picture is that in this region f is bigger than g, and in this region g is greater or equal to x. So, if we kind of if we find a point C, then we will apply this. So, what we are going to get here a to c f x minus of g x, and then for this it is c to b g x minus of f x, that is what we are. So, essentially if we write it, so the area, so area between the curves y equal to f x and y equal to g x from a to b A to B is given by mod of f of x minus of g of x dx. So, now for this case from A to C if I take, then mod f x is equal to g f x minus g of x. Now, from C to B mod f x is equal to mod f minus of g is equal to g x minus f x, and g is bigger than that. So, now let us do some example. Find area of the region bounded above by x and bounded below by sin x, y equal to sin x or y equal to x, and bounded on sides x equal to 0 and x equal to pi by 2. So, now if I want to, this is y equal to x, and if this is pi by pi, then our sign will go like this. So, now with the pi by 2 is going to be 1. So, what we want to find is basically this area of this region. Okay. So, by our formula here what we know is that in the region x is always greater or equal to sin x. So, the area is 0 to pi by 2 x minus of sin x dx, that you can easily compute. This is x square by 2 minus of cos x from 0 to pi by 2. You can compute that. I think what you are going to get is pi square by 8 minus 1 maybe. Okay. So, now let us do another example. Example 2, find the area of the region enclosed by the parabola y equal to x square and y is equal to 2 x minus of x square. Both of these y equal to x square and y equal to 2 x minus of x square, both of these are parabolas. So, now what we need to find is it is saying that find the area region enclosed by these two parabola. So, what we need to find that where these two parabolas are intersecting, then that is going to be the area what we should be interested. Let us say where first you do where these curves intersect. So, now in that case wherever they are going to intersect, this point is going to satisfy will be on the parabola y equal to x square, also will be on the parabola 2 x minus x square. So, therefore, in those point this equation should be satisfied. This will imply that 2 x square, this is equal to 2 x. So, this will imply that 2 x square minus of 2 x, this is equal to 0. 2x if we take it common, then this is x minus of 1 equal to 0. So, in from this we say that either x is equal to 0 or x is equal to 1, because there are two factors x into x minus of 1. So, now as you can see, so this is where our y equal to x square is like this, and if we draw the graph y equal to 2x minus of x square, this is going to be a parabola which is going to look like this. So, this is the region what we are trying to find the area. Now, essentially our x is going now moving from 0 to 1. Now, pictorially we can see that actually in this region this is equal to 1 and this is 0. In this region 2x minus x square is dominating y equal to x square, at least pictorially, but let us try to prove that 2x minus of x square is greater or equal to x square if and only if x, this is 2x is greater or equal to x square, 2x is greater or equal to 2x square. Therefore, this is if and only if x has to be less or equal to 1, then only x is greater than x square. So, the modulus of the difference of the function here is actually, we know that in this region 2x minus x square dominates. So, the area is integral 0 to 1 2x minus of x square minus x square dx. If you compute that, this is an easy computation. So, you will get that this is 1 upon 3. Okay. So, let us do another where we need to change f and g, modulus is different. So, example 3, find the area of the region bounded by the curve y equal to sin x, y equal to cos x, x equal to 0 and x equal to pi by 2. So, let us try to sketch the graph. For 0 to pi by 2, x equal to 0 is this, x equal to pi by 2 is this is two straight line we have got, and then sin x, this is, let us take 1, sin x is something like this is our sin x, and cos x is. Now, what is the area which is bounded by this true curve? So, now if you look at this area, so basically the region which is bounded by these 4 curves are this region and this region. This is what is the region bounded by this 4 curves. Okay. So, now how to find the area? So, now we need to figure out what this point is. This is the point which is lying both on the curve sin x and both on the curve cos x. So, therefore, we can say that this is the point where sin x is equal to cos x. This will imply that x equal to pi by 4, and we are only interested from 0 to pi by 2. So, this is pi upon 4. So, therefore, the area is equal to, we can take 0 to pi by 4. Here in this picture, you see up to 0 to pi by 4 cos x is dominating sin x. So, therefore, this is cos x minus of sin x dx. Now, on this pi by 4 to pi by 2, sin x is dominating cos x. So, this one would be sin x minus of cos x dx, because the modulus is always a positive number. So, now we are in a familiar terrain to compute this integral. This would be easy to compute. I hope that this is what it is going to be the answer of this. So, in finding out the area bounded by the curves, the area of the region bounded by the curves, first draw an intuitive diagram and then figure out how they are behaving and get the point of intersection, and depending on which one is dominating what. So, you calculate the area, because you remember that the area comes with the mod of f of x minus of g of x. So, you need to know the behavior of f and g in certain parts of the domain. So, that, and sometimes suppose we had been given with something like to find an area of let us say here, and we want to find the area of this. We want to calculate the area of this. So, this becomes pretty much complicated if we want to write in terms of the area to be f of x minus of g of x. However, sometimes it becomes pretty easy that if y is f of x, then we can write x in terms of y, and maybe it will be easier for us to calculate the area. So, for certain region, if we treat the function to be x as a function of y. So, let us see for this concrete example. So, find the area enclosed by the line y equal to x minus of 1 and the parabola y square is equal to 2x plus 6. This is tentative figure of this region what we have drawn it over here. So, the point of intersection first we need to find. Is x minus of 1 square, which is equal to 2x plus 6. This will imply that x square minus 2x plus 1, which is equal to 2x plus 6. So, this will imply that this is x square minus of 4x minus of 5 is equal to 0. So, this will imply x minus of 5 into x plus of 1. This is going to be, this is actually, this is not x minus of 1. So, here if I do this, then this is what it is going to be the curve. So, this is the area which is equal to 0. So, this is x equal to minus of 1. Okay, and then this is x equal to 5. So, the points are what? Points are x equal to minus of 1 if you take, then y is going to be minus of 2, because y equal to x minus of 1, and if I take x to be 5, then y is going to be 4. So, these are the point. So, this is the point minus of 1, minus 2, and this is 5 and 4. So, now here what we have got is that x is equal to y plus 1. because y equal to x minus of 1, and here if I write it in terms of x, then this is going to be, this one is going to give us that x is equal to 1 by 2 into y square minus of 6 from this. This is equal to 1 by y square by 2 minus of 3. So, this is again a parabola and this is a straight line, but what we are going to get in term. So, now if you look at the y, if I am taking the region of y, our y is going to vary from minus 2 to 4. So, what we write is that y is minus 2 to 4. Now, you are looking at from the y point of view, then obviously, this line is going to dominate, the parabola will lie under it in a in a sense that you can see this like this, y square by 2 minus of 3 is lesser equal to y plus 1 if and only if y square is lesser equal to 2 y plus 8. So, this if and only if y minus 2 y minus of 8 is lesser equal to 0, if and only if y minus y plus 2 into y minus 4, this is lesser equal to 0. So, now one of them has to be negative, that means if y is greater than minus 2 and less than 4, that is where you are going to get that is negative. So, therefore, y square is by 2 minus 3 is dominated by y plus 1. So, in this case we have y plus 1 minus of y square by 2 minus of 3 dy. This is equal to minus of 2 to 4 and this is minus of y square by 2 plus y plus 4 dy. So, that will be easy to compute and which we are going to get it as this is going to be 18. So, many a times if we write x as a function of y, then it is easier for us to calculate integral of g of y dy and y varies from some c to d to find the area. So, depending on the situation when you have, because if as you can see here we have lot of difficulties in finding the area when if we consider this as a function of x. Nevertheless, but if we convert it into the problem x as a function of y, it becomes very easy, and always be careful about that which is dominating what. So, sometimes it is easier to get carried away, but I would suggest recommend you to for some algebraic equation try to prove it lesser equal to if and only if, then you many a times you are going to get the correct curve which is dominating. Okay. So, now we try to discuss that, let us say we have a curve. Now, we want to find what we did is that we have developed that to find the area of the region bounded by this curve. Now, we want to find the length of the curve. Well, I mean not necessarily that always we can compute the length of any given curve, because we need to define, we need to say intuitively what we understand is this curve is a continuous function. But to define, to be more precise about the curve, we need some more sophisticated mathematics, but for the time being let us consider intuitively. Now, if I want to find the length of this curve, then just look at how I am going to do that. Let me take the equal partition of this A B. This is a continuous graph of a continuous function what I am trying. So, now equal partition. So, here I have, let us say this is P 0, this is P 1, this is P 2, this is P 3. So, this is, if this is x I minus 1 to x I, then this is P of I minus of 1 to P of I. So, now I join this. Like this. As you can see that I may not able to calculate the length of this curve, but we know how to estimate the length of this line. Now, if we go finer and finer partition, so obviously we are going to approach where? We are going to approach the length of the curve, because finer and finer, and in each step what we are going to do? In each step we are going to compute the length of straight line, what we know how to do it. So, we will exploit this idea, and then in the next lecture we are going to find the length of curve. Thank you.